From the auto-ionization of water that we saw in the previous section, we can use the equations above to calculate the pH, pOH, concentration of H+, and concentration of OH-. All of these equations can be used in any order, so depending on what you are given and what you would like to find, we can use these equations in numerous ways. For weak acids and bases, and for a mixture of acids and bases, the calculations will become more detailed, but at the end, when we would like to calculate the pH, concentration of H+, or concentration of OH-, etc., we will always come back to these equations. For our first example, we will calculate the pH and pOH for the following concentrations given. We will also determine if the solution is acidic, basic, or neutral. With the first example, we are given the concentration of protons. To calculate the pH from the concentration of protons, the easiest equation to use and the most straightforward way will be pH equals the negative log of the concentration of H+. Log is a function in the calculator, so I will input negative log 1 times 10 to negative 6. Numbers in scientific notation can be tricky when inputting them into the calculator. If your calculator does not have the double E function, make sure to put parentheses around any number in scientific notation. The double E function is a way to make sure the calculator understands that the number in scientific notation should stay grouped as one value. 1e negative 6 is the same as saying 1 times 10 to negative 6. Double E takes the place of times 10 to the power. So after we input this into the calculator, the pH equals 6.0. And because this value is lower than 7, the solution is acidic. To find the pOH from the pH, we can use the equation 14 equals pH plus pOH. So after I subtract 6 from 14, I get that the pOH equals 8.0. We don't really use a pOH scale in chemistry. However, having a calculation where we can find the pOH will make it much easier to find the pH for problems. In the next example, we are given the concentration of OH-, and the most straightforward way to find the pH and pOH will be to first calculate the pOH and then the pH. I can find the pOH with the equation pOH equals negative log of the concentration of OH-. This equation is very similar to the first equation that we saw with pH and concentration of H+. However, we are finding pOH from the concentration of OH-. When I input negative log times 7.4 times 10 to negative 9th in the calculator, I get that the pOH equals 8.13. From the pOH, I can find the pH value with the same equation we used for the first problem. 14 equals pH plus pOH. When I subtract 14 and 8.13, I get that the pH equals 5.87. Because the pH is below 7, the solution is also acidic. If all of these equations seems like it is hard to navigate and understand which equation to use next, we can use this diagram to help us navigate all of the different ways of calculating the 4 variables. You just start with the variable that you have, and find the variable that is needed, and follow the arrows with the associated equations to calculate. You can use this diagram to help you calculate the concentration of H plus and the concentration of OH minus for these pH and pOH values. Pause the video and take a second to try to calculate the concentrations and determine if the solution is acidic, basic, or neutral. Because the diagram is in the rotation of a clockwise or counterclockwise circle, you can see how you can use different equations to arrive to the same answer. So it's okay if you use a different route to find the same values. For the first question with pH equals 7.56, I can first find the concentration of H plus using the equation 10 to the negative pH equals the concentration of H plus. When I input 10 to the negative 7.56 into the calculator, I get that the concentration of H plus will be 2.8 times 10 to the negative 8th molar. Because these are all concentrations, our units for the values will be capital M, or moles per liter. After finding the concentration of H plus, I can either use 1 times 10 to the negative 14th equals the concentration of H plus times the concentration of OH minus, or I can go back, find the pOH, and then find the concentration of OH minus using 14 equals pH plus pOH. I actually like the second way more because it gives us a better way to manage all of the digits in the calculator. If I start with the pH value first, I won't have to worry about rounding, which can change our answer at the end. So I'm going to subtract 7.56 from 14 to find the pOH. The pOH that I found is 6.44, and then I can use the equation 10 to the negative pOH equals the concentration of OH minus. And 10 to the negative 6.44 will give me 3.6 times 10 to the negative 7 molar for the concentration of OH minus. We can look at the pH, and because it's above 7, the solution will be basic. You can also look at your concentration of H plus and OH minus ions, and negative 7 will be a larger value than negative 8 for the exponents. So because you have more OH minus than H plus, the solution will be basic. For the second problem, we are given the pOH equals 8.21. I will use very similar steps as to the first problem, but I will just find the pH first to make it easier when I'm putting both into the calculator to find the concentration of H plus and the concentration of OH minus. If I subtract 14 from the pOH, I get that the pH will be 5.79. So my concentration of OH minus will be 10 to the negative 8.21, and my concentration of H plus will be 10 to the negative 5.79. The concentration of OH minus will be 6.2 times 10 to the negative 9th molar, and the concentration of H plus will be 1.6 times 10 to the negative 6 molar. From the pH that we found of 5.79, the solution will be acidic. Or we can look at the concentrations for both H plus and OH minus. Because our value for the concentration of H plus is larger than the concentration of OH minus, this will also tell us that the solution is acidic. You may be wondering why I stopped the values from the calculator numbers given in this specific way. Just like with normal significant figures, the log and anti-log functions do have rules for significant figures. We will explore these rules in the next video.